Okay, let's go back. It's all new, so I know when I learn something new, I have to review and repeat and repeat and repeat and repeat and repeat and repeat. Okay. So every time we're asked to determine a limit, what is the very first thing we have to do? We must
plug in.
We must plug in. We have no idea what type of limit this is till we plug it in. Please, that is the key. Like when we graph a function, when we're asked to graph a function, the very first step, the rest it's up to you. You can choose whatever steps you want to perform next, but this must be the first one. When we graph a function. When we determine a limit, no matter what you do next, this must be the first one. Mandatory. Good. Good, so let's plug it in. Because this is another very important concept that I'm getting at, but not this moment. That's the next step. So when we plug in 3 at the top, what do we get?
21.
So we get 9 plus 12, 21. Excellent. Great job. What about the denominator?
0.
Yes. What do we know about this for sure? Before we even consider anything. We know for sure that the limit
Does not exist.
excellent. But we cannot write DNE. We have these options. These are the options. At this point, we don't know which one. Very good. I do recommend factoring it because it's easier to plug in. You can say no, and I'll have to agree. Here's another option that you have. In y equals, if you have your calculators, I'll wait for a second. Let's plug it in. But be very careful if you use the calculator, which I agree with at this point is fine. If you omit to put parentheses around the numerator and parentheses around the denominator, on certain calculators, yes, I agree, there are newer ones, sophisticated ones that know what you mean, but most calculators, I shouldn't say most, many calculators don't. So please put in the left parenthesis for x squared plus 4x, close the parenthesis and divide in parentheses by x squared minus 2x and minus 3, close the parenthesis. All I have to do is just plug in a number to the left of 3. So go to second and table. I'm going to plug in 2.9. I don't care for the number. I do care about the sign. And it's done.
Can you show us that on the calculator one more time? Real
Sure, yes. Do you have the function in?
Yes.
And then you have to go to second and table and plug in a number close to 3. You can say from the left, you can say 1. No, 1 is not close. 2.9 is close. So second and table, and you plug in 2.9 and you get negative 51.31. That's sufficient to write negative infinity. Is that better?
Yes. I can't, on my table, enter in.
So you have to go to second and table set and make sure that your independent variable is in the ask mode, so it allows the calculator will allow you now to put in the numbers you want.
Thank you.
Sure. Everyone else okay? Okay, perfect. So I'm going to add 2 questions. We already have the answers to these 2. I'm going to add 2 more questions for you. You can enter the answers. I'm not going to delete those. So now we're ready to move on to limit laws. So this is 2.3. Limit laws. There are many limit laws that we will use, and in certain situations we basically use them without even thinking. And here are the assumptions. First of all, we haven't started listing them. Assume that limit of f of x as x approaches a from either side is L. Any number, it doesn't matter. And limit of g of x as x approaches a, it also exists, different number. It can be the same, we don't care what the numbers are, but they have to exist. So here's our first limit law, and that's how we indicate they exist. Number 1, limit of f of x plus g of x as x approaches a. What do you think this will equal to? I'm getting myself logged back in. What do you think? Wild guess.
L plus m?
Yes. So what this really means is this. The limit of a sum of functions is the sum of the limits. And no, we're not distributing the limit operator. It looks like it, but that's not what we're doing. This is not a distributive law by any means. So indeed, if this is L and this is M, that's M. L plus M. Number 2. The limit of f of x minus g of x. Of course, the same thing. This is the limit of f of x minus limit of g of x. Again, we are not distributing the limit operator. It looks like it, but we're not. Number 3, limit of f of x times g of x as x approaches a. What do you think this will equal to?
Lm.
Very good. So the limit of f of x as x approaches a multiplied by the limit of g of x. As you see, we would have not been able to distribute or anything like that. So it's not a distributive law. Indeed, L times m. Limit number 4, limit law number 4, limit as x approaches a from f of x over g of x. What do you think this will equal to?
L over m.
So indeed, so we have limit of f of x as x approaches a, limit of g of x as x approaches a, and this is indeed L divided by m, but this one comes with an if. I didn't have an if on the previous ones, but this one comes with an if. Can anyone give us the if?
If the limit of g of x is positive?
I can divide by a positive number and by a negative number.
Limit of g of x is not equal to 0.
That's a different story. Very good. Excellent. Because I can divide by positive numbers, I can divide by negative numbers, but what I cannot divide by is 0. Perfect. Limit number 5. Limit of a constant times a function f of x I think I'm on 10, yeah. Good. So a constant times a function, the constant goes in front as a factor. So this is c times limit as x approaches a from f of x. So this is c times l. Any questions so far? Any questions?
No.
Number 6. Limit from f of x raised to power n as x approaches a. And n is a positive integer, because if it's negative, it's going to be 1 over. So for now, we say n positive, and that's a different story, integer. And I want to draw your attention to something here after you give me the answer. What do you think the answer is?
L to the nth power.
Excellent. So basically, this means limit of f of x as x approaches a raised to the nth power, and this is L and then raised to the nth power. And I'm going to write very, very important concept. I don't want to go into a lot of details now and why and conditions, because this is part of a next section called continuity. But here's a concept that I would like you to be aware of. You notice what I did here? Now, how do we call the limit? What did we say at the very beginning when we started? What did we say about the limit? The limit is a
Operator.
It's an operator. Log is an operator, square root is an operator, the cube root is an operator, power 5 is an operator, absolute value is an operator. What did I really do here? With this operator and this operator, what did I do to get this? I swapped the operator, swapping the operators. Switching, I switched the operator. This operator was outside, and this operator was inside, touching the function. Now, the limit operator is touching the function, and the operator that initially touched the function is outside. So I swapped their order. What is the order here? Take the function to the nth power and then apply the limit. But this is not the same order here. This one says apply the limit to the function, and when you're done, take it to the nth power. So n was the inner operator, limit was the outer operator. Now limit is the inner operator and n is the outer operator. Swapping of the operators. And this is possible only, I'm just going to mention that there is a theorem that we can discuss later. Under conditions, not always, that's not always possible. Under conditions of continuity. We don't know that yet. We haven't talked about it. Only. Under conditions of continuity only, we can swap the operators. Very important concept. We're going to use it a lot later. Okay, number 7. Limit of the nth root of f of x as x approaches a. Of course, n has to be a positive integer, otherwise it's 1 over and it's a different story. Also n positive integer. The same thing I do here. I swap the operators again. The operator that was touching the function becomes the outer operator, and the outer operator will touch the function, becoming the inner operator. Because this is L, this will be the nth root of L. Any questions so far?
No.
Thank you. So there are others that I don't personally consider limit laws, but they are listed as limit laws, and okay, fine. So here's one. Limit, that's not a good color, sorry. So limit of a constant as x approaches a. What do you think that is?
Constant.
Say it again? Of course, yes. Number 9, limit of a simple linear function as x approaches a. And then I would say, plug it in. And when you plug it in, what do you get? That's it? 10? Same thing, same idea, really. I do not consider these limit laws, but anyway. X approaches a from x to the nth power. Just plug it in.
To the nth power.
Good. And the last one, again, I do not consider these limit laws. So the last one is limit as x approaches a from the nth root of x. Of course, n positive integer.
The nth root of a.
Yes. So I would consider the first 7. Your book lists these, and I said fine, but they're just common sense. These are common sense, and they are based on what we discussed as limit laws. They are not standalone anything per se, but that's fine. Okay, so we are ready to look at tons of examples now. And I would like to start with, these are exercises from 2.3. Let me see where I'm with the time. So let me